Here this question is asking, use direct integration to find the inverse Fourier transform of GC of f is equal to delta phi f minus 2 delta f minus 0.5. Okay, here we have the question given in frequency domain, and we are trying to convert into time domain. If you look at the Fourier transforms, we will have this function will be given in time domain and asked to frequency domain. So they are only a little bit different in doing this stuff. To convert a frequency domain to time domain, this is the equation we have to use. GC of t and the integration from negative infinity to infinity, and whatever the function we are trying to do the inverse transform should be right here, and then that one multiplied by e power j 2 phi f t, and then this one will be integrated with respect to frequency. If you look at the Fourier transform, you will see something similar to this. This will be in time domain, and you will integrate this in respect to time, and here you will have a negative. But for frequency domain, you will have a function with respect to frequency, and this is positive, and you will integrate this respect to frequency. Okay, that's the difference. Now instead of this, we can plug this function, that is integration negative infinity to infinity, that is delta of phi f minus 2 delta f minus 0.5, and we multiply the whole thing by e power j 2 phi f t df. Okay, so this is the one we have, and here we had to use one of the property to remove this coefficient in front of this delta. That is when you have delta of at, you can rewrite this one as 1 over absolute value of a delta of t. Okay, here we are going to do the same thing. So but before that, we can multiply this and write it separately. Let's do that. Negative infinity to infinity delta of phi f e power j 2 phi f t, and then minus 2 delta of, okay, this one I had to put integrating negative infinity to infinity, and then 2 delta, 2 is a constant, we can write it to the front. Okay, and then 2 delta of f minus 0.5 multiplied by e power j 2 phi f t, and here also there will be a dt, df, we are integrating with respect to frequency, and here also df. Okay, so this one I can write it as 1 over, if you have delta of at 1 over a delta of t, so like that. If you have delta of phi f, then 1 over phi delta of negative infinity to infinity, and then delta of f right here. And if it's delta of f, then this is only going to happen at when the time is equal to 0, because impulse function happen only when the time is equal to when the time of frequency, like whatever function, whatever is related to, when that one is equal to 0. So here this is in the frequency domain, so delta of f, so f is equal to 0. Therefore we can substitute that 0 for this one, because this is only going to happen at 0. In other point it's going to be 0. So e power j 2 phi, instead of the frequency I put a 0 for it, and then t. Okay, and we are integrating with respect to frequency. And then for the next one, we have minus 2 here, and then negative infinity to infinity, and this one also similar to this, delta of f minus 0.5, and this one is only happening at 0.5 because if you solve for this, f minus 0.5 is equal to 0, and then f is equal to 0.5. So it's only happening at 0.5 hertz. So this is gonna only exist at 0.5 hertz, and other places is 0. So when for this f right here, we have to just substitute 0.5. E power j25 times 0.5 t df. Okay, so once we substitute these values, now this one become constant because we don't have a f anymore. We are integrating with respect to frequency, so this value is a constant right now because we don't have anything with anything f right here. And this one also constant because we don't have we substitute the f 0.5 here. Okay, so once we are done that, then this is the only integration left, that we are integrating an impulse function. Okay, and if we integrate an impulse function, that's always 1, so all the things get removed, only the constant will be remaining. So 1 over 5 here, and then this is e power j25 0t, that's gonna be just e power 0, and then minus 2, and here same thing, this is going to be e power j25 0.5t. 0.5 is 1 over 2, so you can cancel this 2 and 2, so this is going to be e power j5t. Okay, so that's the thing gonna remain. So at the end we can just put it as e power 0 is 1, so this is just 1 over 5 right here, and then minus 2 e power j5t, and that is the inverse Fourier transform of the given function. And that's it for this video. I hope you guys found this video helpful. Thanks for watching. Don't forget to subscribe my channel. See you guys on my next video.